So now we're going to have the formulas for sine. And again, these are sum and difference formulas. Okay, so if you have sine of alpha plus beta, that's equal to sine alpha cosine beta plus cosine alpha sine beta. So I remember, okay, when it's sine, you know, you have one of each, sine and a cosine. And then the sine, though, the S-I-G-N, stays the same. So unlike the cosine ones. Okay, so plus here, plus there. So the same thing's going to happen with the difference, sine alpha minus beta. It's going to be sine alpha cosine beta minus cosine alpha sine beta. Now, there could be other ways to write it, you know, because multiplication's commutative, addition's commutative, but it's better to be consistent. And notice that they put the alpha one first and then the beta one, alpha first, then beta. That's just for consistency, and I recommend following it that way. Okay, so now we have an example. Use the sum and difference identities to evaluate the differences of the angles and show that part A equals part B. Okay, so why would part A equal part B? Well, what's the difference here? 15 degrees, right? 45 minus 30. And what's the difference here? 15 degrees. So they should be equal to each other, A and B. So we're going to practice using the difference formula. So let's see. I can write it. Sine alpha minus beta, even though we just had that. Sine alpha cosine beta minus cosine alpha sine beta. Okay. So now part A. Alpha is going to be 45 degrees, so alpha is 45, and beta is 30 degrees. Okay, so using the formula then we get sine 45 degrees cosine 30 degrees minus cosine 45 degrees sine 30 degrees. So this is part A. All right, I think I got all my alphas and betas where they're supposed to be. So what's the sine of 45? Square root 2 over 2. Cosine of 30 is square root 3 over 2. We've seen this before. Minus, now what's the cosine of 45? Square root 2 over 2. And what's the sine of 30? 1/2. I feel like we've seen this before. But not surprising because we keep seeing the same special angles, right? Okay. So you get the square root of 6 minus the square root of 2, and I'll just put it all over 4. Okay, so that one's done. But what about part B? Well, we're going to use the same formula, but it's going to be different because we're in a different quadrant, right? Okay, so we're going to have sine 135 cosine 120. Well, I was going to put that in parentheses, but let me take that out. Okay, 120 degrees minus cosine 135 degrees sine 120 degrees. Okay, now where's 135 degrees? Well, it's going to be over here in the second quadrant, right? But the reference angle is 45 degrees. Sine is positive in the second quadrant, so my sine's going to be positive. So this is going to be the square root of 2 over 2. Cosine of 120, I'd have to draw like a new grid system. 120 is right there. Reference angle is 60 degrees, right? So 60 degrees. But second quadrant is going to be negative because cosine's negative over in the second quadrant. So I'm going to get a negative, let's see, cosine of 120, 1/2. You could remember your cofunctions. Sine of 60 degrees is 1/2, so cosine of 60 degrees is 1/2. No, I just strike all that I said. So it has to be, just like strike that out of it. it has to be the complementary angle. So sine of 30 degrees is equal to the cosine of 60 degrees. Okay, that's what I meant to say. All right. Sorry about that. Okay, now we'll do the other part. Cosine of 135, well, that's going to be negative, right? Because you're over in the second quadrant, so it's going to be negative square root 2 over 2. And then the sine is going to be the square root of 3 over 2. That will be positive because sine's positive in the second quadrant. Okay, so we multiply stuff out, and what do we get? Negative square root 2 over 4, and then we get minus a negative square root of 6 over 4. So minus and minus, that's going to be plus. You know, let me scroll it up a little bit. I'll just write it out for you. But that's the same thing, right? Okay, you could write it one more time if you want to. So they were the same. Okay,